Alright, so in this video, I'm going to be solving the equation 5 to the power of x is equal to 50. So to first start with this problem, let's test different values of x. So if x is 1, then I get 5 to the power of 1, which is equal to 5, and this is too low. Now if x equals 2, I get 5 to the power of 2, which is 25, and this again is too low. Now if x equals 3, then I have 5 to the power of 3, which is 125, and this is way too high. So we know that the value of x is going to be somewhere in between 2 and 3, meaning it's going to be a decimal. So how are we going to find the exact value of x? Well, to start, we're going to be using logarithms. So I'm going to take the log on both sides, so I get log 5 to the power of x is equal to log 50. And the reason I'm doing this is because logarithms come with a special property that state that if I have something in the form log a to the power of b, I can actually move the exponent b to the front, so this turns into b times log a. So in this case, I have log 5 to the power of x, and we can think of x as b, and I can move this x to the front, so now I get x times log 5 is equal to log 50. And now remember, we want to find the value of x, so all we have to do that is to get rid of this log 5 by dividing both sides by log 5. So now these two cancel out, and I get x is equal to log 50 over log 5. And now let's simplify this a little to get the exact decimal value. So log 50 is the same thing as log of 10 times 5. And another property of logarithms is that if I have something in the form log of a times b, this is equal to log a plus log b. So now this turns into log 10 plus log 5 over log 5, which is the same thing as log 10 over log 5 plus log 5 over log 5, which is just 1. And log 10 is also equal to 1. So I get x equals 1 over log 5 plus 1. So now all that's left to do is do 1 divided by log 5 in my calculator. So I get x is equal to 1.431 plus 1, which is equal to 2.431. So this is my answer. Alright, so in this video, I'm going to be solving the problem 9 to the power of 900 minus 9 to the power of 901. So, to solve this, I'm going to first start by evaluating my terms. So we have 9 to the power of 900 and 9 to the power of 901. And these two terms are pretty similar, except that the exponent for 9 to the power of 900 is 1 less than the exponent for 9 to the power of 901. So the easiest way to solve this is to simplify this as much as we can. And a way to do that is to factor out a term. Well, 9 to the power of 900 is actually a factor of 9 to the power of 901. So all we have to do is rewrite 9 to the power of 901 as something times 9 to the power of 900. Well, we can use properties of exponents to do this. So I'm actually going to rewrite 9 to the power of 901 as 9 to the power of 900 plus 1. And now I can use the exponential property a to the power of m plus n is equal to a to the power of m times a to the power of n. So I get 9 to the power of 900 minus 9 to the power of 900 times 9 to the power of 1. So, now from here, these two terms have the number 9 to the power of 900 in them. So I'm going to factor out 9 to the power of 900, which is what I said I was going to do at the beginning of the video. So now I get 9 to the power of 900 times 1 minus 9 to the power of 1. And this is equal to 9 to the power of 900 times 1 minus 9, because 9 to the power of 1 is the same thing as 9. Now 1 minus 9 is equal to negative 8. So I get 9 to the power of 900 times negative 8. Now from here, I said I was going to simplify this as much as possible. And we can't really get the exact value because 9 to the power of 900 is such a big number that we can't actually get the exact value for that. However, what we can get is the simplified value, and we're going to simplify it as much as possible. So I'm actually going to move this negative sign to the front. So I get negative 9 to the power of 900 times 8. And this gets me negative 3 squared to the power of 900 times 2 to the power of 3. We're simplifying these terms as much as possible. So I'm going to use a quick exponential property that states that a to the power of m to the power of n is equal to a to the power of m times n on 3 to the power of 2 to the power of 900. So I get negative 3 to the power of 1800 times 2 to the power of 3. So this is my final solution to this equation. Now, if you haven't already, please make sure to subscribe, leave a like, and even show this to any of your friends and family. That would support me a lot. I have a bunch of other videos similar to these on my channel, and if you're up for any challenges, I have a bunch of those, so please make sure to check them out. And thank you for watching. Bye.